Triconix controllers are designed specifically for both safety and critical control applications in high-hazard industries where safe operations are critical and reliable operation is paramount. As a safety and security certified system, the high-integrity, highly available, fault-tolerant controller helps provide operational integrity, protection against inherent risks and hazards, as well as external threats like cyber attacks. The triple modular redundant design employs 3 isolated parallel control systems and extensive diagnostics all integrated into one system. The system uses 2 out of 3 voting to provide high integrity, error-free, uninterrupted process operation with no single point of failure. So how does it work? Every I/O module houses the circuitry for 3 independent legs. Each leg on the input module reads the process data and passes that information to its respective main processor. Then, the 3 main processors communicate with each other using a proprietary high-speed bus called Tribus. Once per scan, the main processors synchronize and communicate with their neighbors over the Tribus. The Tribus votes digital input data, compares output data, and sends copies of analog input data to each main processor. The main processors then execute the control program and send outputs generated from the control program to the TMR output modules. The Tricon controller votes the output data on the output module as close to the field as possible to detect and compensate for errors that may occur between the main processor and the final output driven to the field. Extensive diagnostics on each channel, module, and functional circuit quickly detect and report operational faults by means of indicators or alarms. Diagnostics are automatic. No special programming is required. Each I/O slot can contain 2 identical I/O modules, which means if a fault is detected on one module, control is automatically switched to the healthy module. A fault-detected module can also be replaced online when only one module is installed in the slot. In this case, a healthy module is inserted in the hot spare slot and the control is switched to this module, which allows the fault-detected module to be pulled and sent for repair.
Now, let's see the entire process in action.